Hello, good day once again. We are here with another lesson with a moment of science with Mr. Rabino. So, in our previous lesson, we talked about the different regions of the electromagnetic waves, along with its practical applications and some of its useful and harmful effects to us. Now, in this lesson, we are going to deal in deeper context about the effects of electromagnetic waves to humans and the environment. So, let us now sit back, relax, and enjoy a wonderful moment of science. Almost everywhere, we are surrounded with a lot of gadgets. And most commonly, these gadgets emit EM radiation, which could pose harm not only to us but also to other living things as well as to the environment. Some of these electromagnetic radiation carry enough energy to pose danger in our health, sometimes compromising our health and our well-being. So that is why for this lesson, we are going to deal with the different effects of electromagnetic waves to humans and the environment. So our main objective for this lesson will be to number 1, to have a description of the possible effects of electromagnetic waves to the living things and the environment. And we will also explain, this is according to the most essential learning competencies from DepEd, explain the effects of EM waves to living things and the environment. And lastly, we will explain the importance of learning to manage the effects of different regions of the EM waves. So now that we are set with our objectives for today's lesson, let us now move on with our main topic for discussion. So, let's have first a recap of the different regions of electromagnetic waves. So, we showed in our previous lesson about the electromagnetic spectrum. We have the radio to from radio waves to gamma rays, and they are arranged accordingly to some of the properties of a wave, like the frequency, the wavelength, and the energy. In the order of increasing energy, EM spectrum is arranged from radio to gamma rays, right? Because we are talking about increasing energy. But if it is arranged in the order of decreasing wavelength, it's still the same way around. It's still from radio waves to gamma rays because gamma rays have the shortest wavelength. But if we arrange the electromagnetic waves into decreasing frequency, it's now a reversed process. It's from gamma rays to radio waves because radio waves have the lowest frequency. And in our previous lesson, we even described the relationship between these three properties. And that is, the higher the energy, the higher the frequency a wave carries, and the shorter is its wavelength, and vice versa. Now, why do we have to talk and go back to these basic properties of EM wave? Simply because here's what you need to know. As what I've said, you are surrounded or we are surrounded by a lot of gadgets that emit infrared radiation. And usually, the hazards that are brought by EM waves are dependent on the energy that it carries. Or in this case, we can also say it's depending on the frequency that it carries, because the higher the energy that a wave carries, the higher the risk of developing an EM radiation hazards. That is why in this case, as what I've mentioned in our previous lesson, gamma rays have the highest energy. That's why it is also the most dangerous EM wave to handle. That is why it is used only in a controlled basis. And what are some of the factors that determine your risk of developing an EM radiation hazard? So let's identify them because we don't know. you might be having or experiencing these factors right now. Number one, the dose or the amount of radiation that you absorb. Well, that's important because the higher the dosage of the EM radiation you absorb, of course, the more risk that you will develop. But please don't get me wrong. Like, for example, there are certain times that, or there are certain um, scenarios wherein you absorb a lot of radiation a year. Let's say in a year basis, you absorb a lot of radiation in a year, but not in um, a single absorption process, but in a collective basis. Like for example, it's collected on a yearly basis. Like for example, you have an X-ray this month, and then you also have another X-ray on the next 2 months, no, something like that. So that is not dangerous. But what's dangerous here is that when you receive an amount of dosage that is of high amount in a short period of time, and that is somewhat, it could pose danger to you. So you have to be careful about that one. So another thing is that your length of time of exposure. Of course, the more you are exposed to EM radiation, the more you develop the risk of EM radiation hazard. Like specifically as of this time of education, right, wherein we are more into online distance learning, and we cannot avoid the fact that we are too much exposed with gadgets because we have to attend our online classes, right? So that's why you have to see to it that you control your length of time of exposure in order for you to avoid some of the harmful effects of EM radiation exposure. So next, the intensity of the radiation that you receive. Of course, that would depend on what type of radiation that you are absorbing, whether it's a radio or a microwave or an infrared or an ultraviolet and so on. Because the higher the energy that an EM wave carries, the more dangerous it is. You have to remember that. Of course, your location could also determine your risk. So, are you living in an area wherein there are a lot of um let's say radioactive materials, like in those now of the nuclear power plants, or are you surrounded with a lot of cellular sites and telecommunication structures? Well, that could also somewhat pose some significant effect on you. And even your ownership of many gadgets or devices, because those devices also emit not infrared, rather, sorry. So infrared, uh, it emits, sorry, it emits an EM radiation, right? So you have to somewhat evaluate yourself. Are you that much of a gadget user a day? Like for example, do you use cell phones on in a longer basis, right? Because maybe we cannot imagine, of course, nowadays without having cell phones, right? So it seems that it would be some a basic necessity already to have these cell phones, no? And but it could also, you can also take into consideration that factor that your longer exposure to these devices could also put risk on your health, or having developed a an EM radiation hazard, and many more. There are still a lot of hazards to talk about, or factors to talk about, and we are just somewhat mentioning here the most common factors that could um, help trigger the development of EM radiation hazard. So now, in an EM radiation class, it could be ionizing or non-ionizing radiation. So, what's the difference between the two? It's important that you know what is ionizing and non-ionizing, because it will help you understand more the dangers that are posed by each type of radiation. So, let's deal with ionizing first. So this is ionizing radiation in a nutshell. Now, to understand ionizing radiation, you go back to the concept of ionization. Okay? So to go back to the concept of ionization, consider this illustration here. In a neutral atom, of course, it is well known fact that in a neutral atom, the number of electrons is equal to the number of protons. Now, what happens if there is an unequal number of protons and electrons? So that is what we call as ions. Because if there is a lack of electron, or shall we say an increase in the number of electrons, making the number of electrons and protons unequal, it would create a charge on your atom. This is what you call as ions. And in fact, they are categorized into two. We have the cations and the anions. Now, how exactly an ion is created? Well, an ion can be created by introducing a high energy in your atom. Now, if your electrons absorb enough energy in order to be knocked out in its energy level, that is what you call as ionization. Meaning to say, there is enough energy that could knock out the electrons, or that could enable these electrons to jump into higher energy level. That is what you call as the process of ionization. And the energy that is needed in order to knock the electrons out from its energy level is what you call as the ionization energy. Now, why do we have to understand this? Now, it's because if an EM wave carries a very high ionization energy, enough to knock out the electrons out of the atom, it could be very dangerous. And in fact, ionizing radiation is dangerous. It can cause mutations in your DNA that may lead to abnormalities in your body or to an offspring. Like for example, like this pig here and this child here. They are actually victims of the Chernobyl accident that happened in Ukraine. But you have to take note that it didn't happen instantly, but instead it happened to their parents, and eventually the exposure of the parents to radiation altered the DNA of the offspring, which resulted to the abnormalities that you see right now on your screen. So that is one of the effect of ionizing radiation. And it may trigger the development of cancer cells, which is, of course, one of the most fatal diseases, right? That is why, as what I've told you, radiations of high ionizing energy are used in controlled fashion, like X rays and gamma rays. So, what happens when a cell is exposed to radiation? Well, several things could happen. Number one, the cells may die because of a high ionizing radiation or energy that an EM wave carries. Or it could be that the cell just continuously divide and nothing happens. But what's dangerous is when a cell exposed to a radiation, and after the exposure, the cell divides abnormally. Now, when a cell divides abnormally, unlike the usual cells which observes boundary during mitotic division, in a cancer cell they don't observe that. They just multiply and multiply without observing boundary, and this is what or how a cancer is produced. Okay, so let's move on. Now, in contrast, non-ionizing radiation are those e- um, regions of the EM waves from radio, micro, infrared, visible light, and the some of the regions of the ultraviolet spectrum. So, non-ionizing radiation is much less dangerous than ionizing radiation, but you still have to be careful because overexposure to this non-ionizing radiation may lead to any of the following effects: sunburns, or the development of cataract in your eyes. So those are some of the effects, and even poor eyesight. So, like for example, if too much exposure to ultraviolet radiation can lead to sunburns and also skin cancers. Hopefully, it will not happen to us, right? And it could also develop into cataract, like when you are exposed to a microwave radiation. That's one danger that that could happen to you, and even experiencing having a poor eyesight, no? Like me, I was overexposed with the radiation with my gadgets, so that's why I have a poor eyesight right now. So that's one aspect that you have to be careful when you are exposed to non-ionizing radiation. Yes, they are less dangerous, but when you are overexposed to it, that could lead to certain harmful effects. Okay, but well, not all EM radiations is harmful all the time. In fact, they are used in some useful fashion, like in the food processing, wherein do you have this so-called food irrigation, wherein we expose food and vegetables into high energy carrying particles like gamma rays in order to kill the bacteria in the food, and it is a safe type of food preservation technique. And in fact, most of the foods that we take into right now are actually exposed to radiation, because without exposure to radiation, maybe our fruits and vegetables will be inhibited by bacteria, and that is not something that is not good, because number one, it could reduce the shelf life of the fruits and vegetables. At the same time, it could also pose harm to our health, right? And the same time, very common in radiotherapy, which is primarily used in treating cancers, or in oncology, which is the science of the curing of cancer, right? And genetically modified organisms, or the GMOs. Wow, you don't know that they are using actually radiation in this case. Well, how is radiation applied in genetically modified organisms? Well, um, we alter the genes of the organism by the process which we call as the mutagenesis. In this case, we use a high energy carrying EM radiation to target specific gene sequence in your DNA. And once this happens, it could result to a change in the characteristic of the fruits and vegetables. Like for example, this picture here shows us a control group of a tomato that is not exposed to radiation for mutagenesis versus um, genetically modified tomatoes. So there, as you can see, in 45 days, the normal tomato is already rotten, but those genetically modified organisms lasted longer. And there are still several effects of how genetically modified organisms can benefit us, because it can improve the yield, like for rice, the taste, even the texture, the size, the quality, and the color of the fruits and vegetables. But GMOs, some are also in the hot seat right now, because there are those groups that believe that GMOs are harmful to our body, since their primary notion is that altering the genetic sequence of the organism could also lead harm, or could also pose harmful effects to us. But many scientists believe that genetically modified organisms are actually safe to eat and safe for consumption. And we will not be dealing with the argument about this um, anti-GMO people and the pro-GMO people, because that is not what's the focus of this discussion. What I am simply trying to tell here is that these are some of the things that EM radiation can do to our food industry. Okay, and to summarize everything, there are beneficial and harmful effects of EM radiation. And it is always a fact in everything that too much is always bad for you, even radiation. That is why we have to take steps in order to minimize your exposure to EM radiation. And that is why, before we end our lesson, I would like to share to you some basic tips simple tips that you can follow in order for you to minimize your exposure to radiation. Just follow this strategy. I call this as the TDS strategy. So time. So you have to lessen your time of exposure to your radiation. If less time near the source, less radiation received. So change your practice. Like I know some of you are very much exposed to your cell phones and other gadgets. So find time to lessen your usage to it. Like for example, like limit to 1 hour of social media and then you take a rest after that, or spend the rest of your time doing other activities that would help contribute to the health of your body. And next, distance. The greater your distance from the source, less radiation received. So how do we apply this in our homes? So like when you're watching TV, you have to watch not too close to the TV. In fact, there is a recommended distance about it. So just research that one on the internet. I don't have the enough information about how far should you be in front of your televisions. And shielding. Behind shielding from source, less radiation received. Like for example, the ones that I'm using right now, I am using an anti-radiation glasses. So in this case, you can also have other sorts of instruments that you can use. And even what's trending right now is the use of plants, no? Because there are some plants that help absorb radiation. So you can even apply that strategy in your homes. So in summary, everything should be taken into moderation, including your absorption and exposure to electromagnetic radiation. Because, as what I've said, though EM waves have posed a lot of benefits in our society, if you are overexposed to it, it could lead to harmful effects. That is why it is important to learn how to manage the effects of this EM radiation exposure. And that is actually the end of our lesson for this encounter. So, let me end our lesson by saying that EM radiation is vital in the development of our society. But along with its contributions made in the society, it can also pose danger to us if you don't know how to manage the effects brought by the radiation it carries. So that is why it is important for you to practice safety precautionary measures in dealing with EM radiation exposure. And that would actually end our lesson for today. So I hope that you have learned something out from our discussion for today. So in case you have questions, you have clarifications, or you have some recommendations regarding our lesson, you may email me personally or you may chat me through my messenger account, which I'm going to post in the description link below. So, thank you so much and God bless us all. And I hope that you have enjoyed some moment of science with Sir Rabino. Bye!